Sathyabama Institute of Science and Technology.
Good morning. I am Dr. C. Bhuvaneswari, Assistant Professor from Department of EEE, Sathyabama Institute of Science and Technology. So today we are going to discuss about voltage source inverters. Inverter is a device which converts DC power into AC power with desired output voltage and frequency. Input DC voltage remains constant, but output AC voltage, magnitude and frequency get changed. So inverters are mainly used in adjustable AC drives, battery driven vehicles, HVDC transmission lines and UPS. So inverters are classified depending upon many methods. So first let us divide based on the methods of commutation. It is classified as line commutated inverter, force commutated inverter. Based on the connection, it is classified as series inverter, parallel inverter and bridge type inverter. Based on the type of input, we classify it as voltage source inverter and current source inverter. So today we are going to talk about three-phase voltage source inverter. So in three-phase voltage source inverter, we have a big classification about 180-degree conduction mode and 120-degree conduction mode. So today we will be discussing about 180-degree conduction mode. So this three-phase inverter is a 6-step bridge inverter. A step can be defined as a change in firing from one SCR to another SCR in proper sequence. And we have 6 SCRs in 180-degree conduction mode. So we will be generating a 3-phase output and totally 6 interval, each interval will have 60 degrees. This is the circuit diagram for the 180-degree conduction mode. 3-phase inverter has 6 SCRs, T1, T2, T3, T4, T5, T6. In this, T1, T3 and T5 are going to be positive group of SCR and T4, T6, T2 are called as the negative group of SCR. And we have 3 phases A, B and C. Thyristor T1 and T4 are connected in phase A, T3 and T6 are connected in phase B, T5 and T2 are connected in phase C. Vs is going to be the source voltage or the input voltage and this is going to be the load. So we have connected a star load, balanced load. So we will be having a neutral point. So we can measure the phase voltages and line voltages. Phase voltages we will have VAN, VBN and VCN. And the line voltages we will be having as VAB, VBC and VCA. So here we are giving proper sequence, that is the triggering pulse will be given to all the 6 thyristors. This will be the sequence T1, T2, T3, T4, T5 and T6. This is the controlling scheme of the thyristors. T1 is switched on with 0 degree, T1 is switched on at 60 degrees, T3 at 120 degrees, T4 at 180, T5 at 240 and T6 at 300. So this is marked here. So at T1 is turned on at 0 degrees, it will be conducting till 180 degree. T2 will be turned on at 60 degrees, so 60 plus 180 it will be conducting. T3 will be turned on at 120 degree, 120 plus 180 it will be conducting. So likewise we will have 6 modes of operation. So from the graph we can take the conducting SCRs. So in mode 1, T5, T6 and T1 will be conducting. In mode 2, T6, T1, T2. In mode 3, T1, T2, T3. In mode 4, T2, T3 and T4. Mode 5, T3, T4, T5. And mode 6, T4, T5, T6. So this has been generated from the angles of conduction. Next is the switching sequence. So whichever thyristor is connected, we will be considering the polarity accordingly. So if the positive group of thyristor is conducting, so the polarity will be positive. If the negative group of thyristor is conducting, the polarity will be negative. So if we see in mode 1, T1, T6 and T5 are conducting. So we will be having positive, negative, positive. And in mode 2, T1, T2, T6. So the polarity will be positive, negative, negative. In mode 3, T1, T3 and T2. So T1 and T3 are from positive group, so it will be positive, and T2 is from negative group, so it will be negative. So likewise we will be proceeding with the polarities of the voltage. So let us consider the mode 1 operation. Mode 1 operation is from 0 to 60 degrees. So in this mode, T5, T6 and T1 will be conducting. So if we see here in the equivalent circuit, T5, T6 and T1 is conducting. This is the equivalent circuit for this mode of operation. We can see this is going to be a balanced load. These 2 impedances are connected in parallel and we have a single impedance here connected in the negative side. So if they are connected in parallel, we will be having Vs by 3. If we have a single impedance, then we will be having 2 Vs by 3. So with this logic, we can calculate the phase voltage and the line voltage. And the line voltage can be calculated by this formula. V is equal to VAN minus VBN. VBC is equal to VBN minus VCN. VCA is equal to VCN minus VAN. So the mode 1 operation, this is the refined equivalent circuit for the mode 1 operation. So we can see these two resistors or impedance are connected in parallel, and this resistor or impedance is connected in series. So let us calculate the equivalent resistance for this mode. So R equivalent is equal to R plus R by 2. So the total equivalent resistance will be 3R by 2. Let me take I1 is going to be the current of the circuit. So I1 is equal to Vs. Vs is the input voltage divided by total R equivalent. So we will be having it as 2 Vs by 3R. Let us calculate VAN and VCN. VAN and VCN will be equal because you can see here this both are connected in parallel. So VAN or VCN is equal to I1 by I1 into R by 2. So this will be equal to Vs by 3. For VBN, it will be minus I1 into R, minus because it is connected with a negative polarity and we have only single resistance. So we can write it as minus I1 into R. So this is equal to minus 2 Vs by 3. Next, mode 2 operation. This is between 60 degrees to 120 degrees. So here thyristor T1, T6 and T2 are conducting. So this is the equivalent circuit. So we can see here on the negative side we have 2 thyristors conducting, and on the positive side we have 1 thyristor conducting. So VAN will be positive here and VBN and VCN will be negative. So we can see here this both are connected in parallel. So we will be having VAN is equal to I2 into R. Let me take I2 is going to be the current flowing here, and this is equal to I2 is equal to Vs by R equivalent. R equivalent we have already calculated here. So let me substitute that and get VAN is equal to 2 Vs by 3. VBN and VCN will be equal as they are connected on the negative side. So this will be equal to minus I2 into R by 2. R by 2 because we have 2 thyristors connected there. Okay. So this will be equal to minus Vs by 3 after substituting the value for R equivalent. So likewise we will be going through for mode 3 operation also. Mode 3 operation is from 120 degree to 180 degrees, and here thyristor T1, T3 and T2 will be conducting. So VAN and VBN, from positive group we will be having 2 thyristors and from negative group we will be having 1 thyristor. So VAN and VBN will be positive and VCN will be negative. So the same equivalent circuit is drawn with a slight modification, and let me have the current flowing through this circuit is I3. So if it is going to be I3, let me calculate I3 is equal to Vs by R equivalent. So what is this R equivalent? We had already calculated that as 3R by 2. So I3 will be equal to 2 Vs by 3R. VAN and VBN is equal to I3 by 2. So from this we can get the value. And VCN is equal to minus 2 Vs by 3. So if you substitute here, VAN and VBN will be Vs by 3. So likewise we had illustrated for 3 modes. Likewise we have mode 4 and mode 5 and mode 6 also. So this is mode 4 operation. Mode 4 operation is from 180 degree to 240 degree. So here if we look at it, look at the equivalent circuit, we have thyristor T4, T3 and T2 conducting. So this will be the equivalent circuit. VBN, positive group we have 1 thyristor and from negative group we have 2 thyristor. So VBN will be positive, VAN and VCN will be negative, and VBN will be equal to 2 Vs by 3 and VAN and VCN will be Vs by 3. So whatever we had illustrated, we had put here as an equivalent circuit for each mode. So these are the 6 modes of operation: mode 1, mode 2, mode 3, mode 4, mode 5, mode 6. Mode 1 thyristor 561, mode 2 612, mode 3 1 2 3, mode 4 2 3 4, mode 5 3 4 5 and mode 6 4 5 6. So we have to draw all the equivalent circuit for all the 6 modes and we have to find out the line voltage and the phase voltage. So whatever we had found out, we had put in a table form here for each 6 modes, and with this value we will be drawing the graph. VA0, VB0 and VC0 are going to be the phase voltages. VAB, VBC and VCA is going to be the line voltages. So this is how we draw the graph. So let me consider first VA0, VB0 and VC0. So first let us draw for the phase voltage. So whatever we have taken from the chart, from the modes of operation, we are going to put it in a graph. So let me take for first mode of operation, it is Vs by 3. So we are drawn for Vs by 3. So let us first draw for Va0. So this is the value for Va0. So Va0, mode 1 Vs by 3, we have drawn Vs by 3. Mode 2, 2 Vs by 3, 2 Vs by 3 has been drawn. Mode 3 Vs by 3, so this is Vs by 3. Mode 4, it is between 180 degree to 240 minus Vs by 3. You can see here the graph has come down in the negative side. 240 to 300, that is for mode 5. So mode 5, the value is minus 2 Vs by 3. It is going more in the negative side. And mode 6, 300 to 360 degree. So it will be the last mode, and we have minus Vs by 3, it will be drawn here. So likewise, it can be drawn for VB0 and VC0 for all the 6 modes of operation. Let us draw for the line voltage. So to get VAB, we will be having the difference between VA0 minus VB0, and VBC will be VB0 minus VC0, and VCA is equal to VC0 minus VA0. So let us draw first for VAB. VAB, this is the value Vs, Vs, 0, minus Vs and 0 for one complete cycle. So you can see here for mode 1 it is Vs, mode 2 it is also Vs, so we have drawn it like this. Mode 3 it is 0, so we had occupied 0. Mode 4 is minus Vs, so we have drawn it on the negative side, and mode 5 minus Vs, again on the negative side, and mode 6 will be 0, we had come to 0. So likewise, let us check for VBC. VBC is equal to VB0 minus VC0. So if we see, mode 1 is minus Vs, so we have drawn for minus Vs. Mode 2 it is 0, we have drawn for 0. Mode 3 Vs, we have drawn for Vs. Mode 4 it is Vs again, so we had again extended it. Mode 5 is 0, the graph had come to 0, and mode 6 it is minus Vs, we had got it on the negative side. So likewise, we can draw for VCA. So this is the illustration for 180 degree conduction for voltage source inverters. Thank you.